Okay, so our definition first off, what are radians? Well, radians become our second way to measure the size of an angle. So it's just another way of doing that. And it has a number of advantages in doing a lot of things, so that's why we learn both ways. And as you know, you can switch most calculators to degrees or radians depending on what you're working on. And so also, keep in mind that if we do switch to radians, now if you're in physics or something else, you need to switch back. And so that's something you're going to have to start watching. So, this is just a second unit. Use to measure the size of an angle. That's all it is. So the definition and this definition is based on a circle. So by the definition we say that in a circle a central angle that cuts off an arc equal length to the radius of a circle has a measure of 1 radian. So we have this circle, and we cut off a angle, and this angle here we'll call theta. Now, if the arc length we cut off, so if this is my radius from here to here, if the arc length we cut off from here to here is the same, right? So this should be the same. That would equal 1 radian. The angle that cuts off an arc length equal to the radius is 1 radian. So by definition, that's why you make what 1 radian is. So the formula for this, so you can see here that we get this sector of a circle. So we're going to use an S for the arc length. S is this length from here to here. So this S equals the arc length. We have R, the radius goes from here to here. And this is our angle theta. So we're going to say then that by definition, theta is going to equal S over R. It's that ratio. So is this the ratio of arc length over the radius? Something interesting too as far as units go, the length of these, typically would have the same length, maybe they're both in meters or centimeters, but the units cancel out. And so we just say that then the units are in radians. And our abbreviation for radians is RAD. So radians are all RAD is our abbreviation. Okay, so let's see. So just a real basic to start with. That in this one we have a circle of radius 3 centimeters. Cuts off an arc length of 6 centimeters. And so the question is, what is the radian measure of theta? Yeah, it's just, so really this was meant to be pretty basic, but of course we know that theta is S over R. So the arc length is, that's 6. And the radius must be 3. So we say that it's 2 radians. Alright, so that's using the basic definition. Yes. So let's start by looking at let's see, I want to do radians and parts of rotation. Okay, so let's say then that on this coordinate plane we rotated all the way around. I want to know how many radians that is. So we need to go back and think a little bit about some things you probably did way back in 7th grade, 6th grade. If we go all the way around, that's like taking a circle, right? And I'm starting here, and of course I go all the way around the circle. So I know that means my arc length, that means that S, right, is all the way around this. So how do you find the distance around the circle? That's called the circumference, right? Circumference equals what?
Diameter pi.
Okay. Pi times diameter, which would be also equal to pi times twice the radius, right? Because diameter, so 2 pi r, right? 2 pi r. So that means then that theta, right? Theta has to be S over R by definition. So it means that S, if I go all the way around, this is S, right? S is all the way around here. S is going to be the circumference, 2 pi r. And that means I need to divide that by r. So that means that theta is what? 2 pi. All right, now typically we use the exact value 2 pi. We do not, but we could talk about the approximation as approximately 6.28. There's approximately 6.28 radians, right, or exactly 2 pi radians as I go all the way around the circle. So that's a complete rotation, right? That means, right, 360 degrees is the same as 2 pi radians. If we did half a circle, if I came and went, so I started here, I went all the way to here, right? That is half of a full circle, right? In other words, that would be half of 2 pi, which would equal what? Half of 2 pi would be pi, right? So halfway around is pi radians. And if we did a fourth, this is theta, by the way. If we did a fourth, right, this is theta from here to here, that would be half, right, of pi. Halfway, if pi is here, that's half of that, so it'll be pi over 2. Okay? So let's compare degrees and radians. So let's just make a little table here. We'll put degrees on the left and radians on the right. So we said, right, that if we had 360 degrees all the way around, how many radians is that?
2 pi.
It's 2 pi. If we did half, 180 degrees, that is
1
pi. 90 degrees,
pi.
half of that. And in fact, if we did half of that, which would be 45 degrees, we get what? Pi over 4. So we can make those comparisons, and again, let's put that into another way of saying that. On the coordinate plane, so that means that if we start here, if we start at 0 degrees, that's the same as 0 radians. That means right here, again in standard position, going counterclockwise, 90 degrees is pi over 2 radians. 180 degrees is pi radians. 270 degrees. Let's see. So this is 1 pi over 2, 2 pi over 2, right? Because each quarter is pi over 2. This would be, again, 1 pi over 2, 2 pi over 2. This would be 3 pi over 2. And in fact, we could go back up here and say this is also 360 degrees, which is 2 pi radians. Okay, so part 3 today is converting from degrees to radians. Now, we're going to do conversions just like we did in science, like we did in chemistry or in physics. You know, in chemistry you do a lot of the molar mass conversions. Physics, we do a lot of the metric conversions. But in all those, you multiply by a unit fraction. We're going to do the same thing with this. So, So we're going to convert and multiplying by a unit fraction. So we need to come up with a unit fraction to use, and in fact there's a lot we could use. Right? I mean, a unit fraction just says you need the same thing on top and bottom. Right? We have a fraction, a ratio that it has different units, but they equal the same thing. So it's equal to 1 unit when you divide them. So in fact, we could do any of the axes here, any of these points would work, right? I mean, we could say, well, yeah, 90 degrees is pi over 2 for unit fraction, 270 is 3 pi over 2. But the one we typically use, the easiest one to use, is this one. 180 is pi. So since we're going from degrees to radians, we want to cancel out degrees. We put degrees on the bottom. So 180 degrees is pi radians. So this is our unit fraction we're going to use. Again, you could use other ones, but this will be the easiest one to use. So let's run through some examples. Let's start off with one of our really important angles because it's on our special triangles. Let's do 30 degrees. So remember, to convert these, you always will take your angle, 30 degrees, and multiply by a unit fraction. Degrees on the bottom to cancel out with that degrees, and radians on top. Now, a lot of the times, especially, this book tends to give pretty nice numbers, and so you can see that, of course, degrees cancel. What else can I cancel from top to bottom? 0 goes into here, right? And 3 goes into 18 6 times. Which means I'm left with what? Pi over 6. So the answer is pi over 6 radians. So 30 degrees is the same as pi over 6. And that's it. That's all you have to do on these. Answer a couple of other problems. Problem number 2. Let's convert 390 degrees. Again, I'm just going to take and multiply by my unit fraction. 180 degrees on bottom, so it cancels with the pi radians on top. And I look to see what I can cancel. You're going to be asked to answer these things exact, not approximate, and leave them as improper fractions. So what can I cancel here? So I can get the zeros gone, degrees gone, the zeros are gone. Is there a common divisor of 39 and 18?
3.
3 does, right? 3 goes into 39 how many times?
13.
So this will be 13, and this will be 6. So the answer is 13 pi over 6. 13 pi over 6 radians. Let's see. Number 3. Negative 150 degrees, right? Because now we're on the coordinate plane, we can have positive or negative angles. So, negative 150 times pi over 180. Get rid of the 0 and the degrees, right? And then what can I divide in these? 3 goes in negative 15. 5. 3 goes here. 6. Answer is? Good. Okay. Alright, one more example. Let's see, this one, now I think this is paragraph after question in the book. It's 260 degrees, and I think the book has about 3 or 4 different things it wants you to do with this. First, it wants you to convert that to radians. So A, convert to radians. So we're going to take, alright, so that means I take 260 times, again, 180 on the bottom, so it cancels with degrees, pi on top.
13 times 9.
And by both by 2. Okay, that's easy. Again, try to get those simplified to the lowest terms. B, I want to find the reference angle. So let's see. Think back to how we do that. What quadrant is this in?
Positive 3 degrees.
In fact, it's almost on the axis, right? This would be 260 degrees. So my reference angle would be this angle here. How much is that?
80 degrees.
The reference angle has to be 80 degrees. C, I want to convert the reference angle to radians. Okay, so 80 degrees times what goes on the bottom goes on top. That cancels. What can go into 8 and
2.
2? So this would be
4 pi.
4, and this would be 9. So that's going to be 4 pi over 9. Again, we tend to leave radians in these exact values, even though, remember, pi is irrational. So they would actually, if we multiply it out, we get a number, but it's an irrational number.